Okay, hi everyone. My name is Alice Chen, and today I'll be talking to you about cryptocurrencies, and I'll be focusing especially on Bitcoin. And so, what is cryptocurrency? Google tells me that it is a type of decentralized digital currency in which encryption techniques are used to regulate the generation of units of currency and verify the transfer of funds. From a user perspective, Bitcoin is just another form of currency. You can use it to purchase items, buy food, as long as you have an app or a wallet that will store your Bitcoins and be able to make transfers with it. But it's actually very different from the money that we're used to. The first difference is that there is no centralized system of regulation. Whereas our dollar is regulated by a central system, the bank, Bitcoin is not managed by one central authority. Instead, it is made of a network of different users or computers that will mine and constantly try to verify Bitcoin transactions. Second, it relies on encryption techniques that is used for its creation and regulation, which I'll be talking a little bit more about in this presentation. But basically what happens, the transactions will be gathered into a block, and the blocks are hashed, and the hash blocks will be gathered into a larger blockchain, and that will be the ledger of all the transactions. So it comes with all the history of what this Bitcoin has been. And so how does this work? And how exactly does this flow look like? So first we'll take these two cats here, the yellow cat and the orange cat, Alice and Bob. Alice wants to buy, let's say, a toy from Bob, and she wants to pay him using her Bitcoin. So her Bitcoin will be stored in a wallet, which here I'll be using Circle as an example. And when she wants to transfer the right amount of Bitcoin to Bob, the Circle will make a public and private key pair that will digitally sign this transaction. And that is all that happens on this user side here. And then on the other side, once this transaction is signed, the miners, that's a dog, his computer will group this into a new transaction block, and then this will use cryptographic hash functions in order to calculate the right hash. This is a basic flow of how Bitcoin works. I'm going to touch on these two things today, the idea of a digital signature and a public identification, and also how the blockchain of transactions work. And so what exactly is digital signature? The wallet that I was talking about earlier will create a public and private key, which is the private key is used to sign the document and the public key is used to verify. Anyone on the network will have access to your public key and be able to verify that the request is coming from the right owner and that you're not trying to use the same Bitcoin in multiple transactions, because that will be fraud. This is built on the rule that signatures will have to be unforgeable, and no matter what algorithms you use, there is only a negligible chance that there is any kind of forging. And in order to do this, they'll need a good case of randomness for the algorithms that create the digital keys. Then there are also hash pointers, which will point from the current block that you're on to the signature/verification of the previous block. And by signing your digital signature onto this hash pointer, you're effectively signing for the entire block. So the data structure allows it so that when you sign this block, it'll come with the entire coin history and all the previous transactions that this Bitcoin has gone through. And this is also another way that they prevent fraud. So the hash pointer will basically be publishing the entire history when you are receiving this Bitcoin. And Bitcoin uses ECDSA, which is Elliptic Curve Digital Signature Algorithm. It is a complex math library that they use to build their digital signatures. One reason why they use it is because there's a very good store of randomness that allows for a more effective generation of public and private keys. And it's decentralized because you don't need to have only one address when you're using your Bitcoin. You can have multiple addresses, which means you'll have multiple public-private key pairs. And so that prevents people from looking for patterns within your transactions and then trying to figure out who you are based on that. And then we're going to go into the other side, mining data. So I said before, Bitcoin miners are there to verify the transactions. The transactions are grouped together in a block and then they're hashed by miners. But Bitcoin has a very special specification on their hash value form. It has to start with a certain number of zeros. So in order to create different hash values from the same data, nonces, which is just a random number, will be added to your data before it gets hashed. And in creating the hash itself is not very mathematically challenging. Finding a nonce that will generate the hash that meets these specifications is very time consuming. And so there's no good way to predict which nonce will produce what kind of hash. So they have to generate many different nonces and hashes until they find the one that meets the specification. And because each hash value, as I said, will contain information about all the previous transactions. So the hashes of the recent transactions will always include a signature that points to the previous block as shown in that picture in the side. And so when you get your transaction, you'll see everything that has happened before, and you can see who has signed for it, and that's how that is. So when multiple miners try to mine on one block, the one that has the most work embedded is chosen for the blockchain because it is the most verified, and it is harder for it to be replaced or for someone to create an alternative block to take its place. And because when someone wants to create an alternative block, they'll have to convince the entire blockchain that this is the most recent block with the most recent work. And now I'm going to talk a little bit about the hash function that Bitcoin uses. It's called SHA-256. What happens is it takes a message or the data that you're trying to hash, it'll break it up into 512 bits, and if your message doesn't hit 512 bits, it'll add some padding until it does. So what it does, it'll take this IV value, it will add to your message plus your nonce, and then that will go through a function, the function C, and that creates a hash value of 256 bits. And it'll keep doing that until it reaches the end of your blockchain, and then the resulting hash that you get will have your entire blockchain history for that. So why is this a good hash function? It is known to be, one, collision-free. There are no known collisions, therefore each unique hash value means that the message value is also unique. And two, it has hiding properties where if given the output of the function, there's no feasible way of figuring out what your input was. And three is puzzle-friendly because it falls into the idea that each hash value is unique to a specific output. So if you wanted to figure out the nonce that was attached to it, you'd have to guess. You'd have to basically guess for it instead of, it's all guessing. So that's why data mining requires a large usage of CPU power. And once the data has been verified by the miner and the Bitcoin, then the miner is rewarded with X amount of Bitcoins. But this is actually very hard to do, and so the payout's very little. So this is very secure because the return, if you ever wanted to tamper with any of the middle blocks, you would have to go through the hashing and the nonce to figure out like what hash value it'll get, and then do it for all the subsequent blocks. So this is actually very hard to hack into. And if you wanted more information, here are some links that I've looked at. Thanks.